Thank you, Phil. And just to introduce myself, I'm Simon Helm, Senior Programme Manager from the Natural Environment Research Council, and I've been involved in both the GGR programmes for a couple of years now, so it's really exciting to be here today to see all of the conversations. So I think what we're going to do, first of all, is invite the PIs, the project leads of the consortium bids, to give you a presentation in turn, and then we'll do a bit of a Q&A, so please do send those messages in via Slido if you can. First up, we've got the GGREW programme, and so we've got Professor Aidong Yang. Thank you.
Okay, thanks, Simon. Good morning, everybody. So I'm here to give a quick summary of the work we have done in the GGREW project on behalf of the PI, which is Professor Hansen and also the rest of the team. As indicated by the title of the project, the GGR option this project has been looking at is enhanced weathering, which is really about accelerating the reaction between CO2 and water and rock to produce cations and also bicarbonate, which is hopefully going to be stored in the ocean. So that is the basic idea. So the enhanced weathering can happen with different minerals. It can happen with carbonate or silicates, either from virgin rocks or from the waste mineral streams. So the particular source this project has focused on is mine tailings, because this is a stream that is produced at a very large quantity every year at gigaton scales. And also the mine tailings are already available with very small sizes, which is a very nice thing to have for enhanced weathering. So in terms of implementation, there have been a lot of very interesting work done with spreading rock powders or mineral powders in open environment. But the alternative that this project has decided to look at is application through reactor-based schemes, where we can do weathering within a more confined environment, so that in principle a wider range of enhancement measures would be possible. So this project has been done by a consortium of universities listed here, with support from stakeholders, particularly from mining industry, including companies such as Anglo American. So we have tried to work on a number of key questions here. So I'm going to give a quick summary of each of these just to show what we have done. If we start with the first one, so we wanted to find out what is the global CDR, or carbon dioxide removal potential from mine tailings from materials perspective. So we started by screening a large number of mine tailing types and mapping these different types against the theoretical CDR potential on a kind of per ton basis, and also the projected tailings production on an annual basis. So this would create a map to show each of these tailing types, what is their kind of potential to draw down CO2 through enhanced weathering. So from this exercise, we were able to quantify it's in the range of 1.1 to 4.5 gigaton per year that this family of material is able to remove CO2 from the atmosphere. But of course, this range, by the way, this uncertainty, this range reflects the uncertainty in the production stream, the uncertainty in the projection. But this set of numbers haven't considered the impact of kinetics, in fact, in terms of how fast minerals would get weathered. So if we do consider the known or reported kinetics into the calculation, the numbers will be much smaller. It's about a tenth of this total potential shown there. So that basically indicates that improved kinetics is really very important if we really want to achieve the full potential of this family of materials. So among the possibilities to accelerate the weathering or dissolution of minerals, we have been particularly looking at the possible roles of microbial processes. As some of you might know, such processes could manipulate pH by drawing down pH, which is nice for dissolving minerals, or by pushing up pH, which will be a nice environment for drawing down CO2. So what is shown here is really the second part, is with a sulfate-reducing bacteria. You can see the intended role is really driving the pH up, and in fact it did the intention, and you can see there's a positive impact on the increase of alkalinity in this kind of experimental device. So this is just part of the work that, in fact, is still being carried out, being continued at the moment, but it has shown some initial potential in this type of approach. So the next question is, so if we manage to find the right material, if we find a way to accelerate dissolution rates, and we want to do this in kind of reactor-based environment, so the key difference between this weathering within a confined environment through engineered system with applying, say, rock powders in open environment is that we can't rely on wind or rain to deliver air and water. So we have to do this from mechanical means. And that means there will be a considerable, very likely considerable set of resource consumption. So the question here is just to try to quantify the resource requirement. So for this purpose, we looked into a number of possible reactor configurations by means of combination of experimental work and some mathematical modeling work. One thing we have learned very quickly is that, I'm sorry, probably you can't read this because of the color scheme, but one thing we have learned quickly is that there will be a huge water requirement. And that basically points to the use of seawater instead of fresh water, because fresh water will be really a huge burden. Or we can try to produce solid product instead of liquid product, but that would have an impact on the CDR potential that can be achieved. And another thing we learned here is a strong trade-off between energy consumption and the CDR rate, which would then impact on how much space such a system would occupy. So as shown here, there's a strong trade-off between space requirement and energy consumption. I have shown a couple of indicative figures from our modeling work on pure minerals and also tailings mixture. And I have got some energy numbers and area requirement numbers. But just very quickly, I think 2 points to mention here. One is on the energy consumption side. It looks, at least for these numbers, it looks like comparable to the broad range of direct air capture, the DAC options. If we want to draw down the energy consumption, either we try to maybe find more area for that, or we can introduce further enhancement measures. By the way, these numbers were not really for systems involving microbial enhancement. So if we can introduce microbial enhancement, there's a hope to further to draw down the energy number. The second point is that if you look at this tailings number, here you can see these numbers are higher than pure minerals. That is basically pointing to the difficulties of handling tailings as a mixture of minerals, which involve both fast and slow weathering minerals. So that is definitely an issue to be further addressed. Okay, so now if we do manage to find all the right type of minerals in large quantities and get this either weathered through reactor schemes or maybe through other schemes, all these will become eventually alkalinity getting into the sea. So the question is, what will be the ocean response? Will there be a problem there? So the particular work that was done, shown on this slide, is a study on a particular organism, which is very important for open ocean carbonate budget. And what we have seen is that with the increase of alkalinity, it looks like the organism kind of enjoys the environment. So the growth rate gets increased. So there's no bad news there. On the other hand, as a calcifier, the calcification rate seems to be also increasing with a larger alkalinity in the water. So that is something to be monitored on, because that would have an impact on the net CO2 removal that the system can achieve. Finally, just on the social and legal regulation perspective. So our social science team have looked at different levels of governance and just identifying potential issues. I think the good news is that there's no showstoppers identified in terms of social acceptance, but some common issues have been flagged up, particularly the monitoring, reporting, and verification. On the regional scale, so for example, through engagement with stakeholders in South Africa, some specific issues were identified, such as water scarcity issues and also the ownership of tailings. These are the issues that we really need to consider in future development. So just very briefly, I think I hope I have shown you that through the project, we were able to discover new knowledge in this area of enhanced weathering with a focus on mining tailings in terms of the CDR potential of the materials and the resource requirements, which will have an impact on the economics and also the net CDR removal, particularly in terms of the energy consumption. So the costing part and the LCA part, we are still wrapping it up, and with hope that we can report in the near future. And from the environmental and social perspective, no showstoppers, but a couple of issues identified. Of course, the work is still being continued. I showed here a couple of areas, microbial enhancement, oceanic response, and tackling fast, slow minerals mix. I think these are the areas we are hoping to do more work for, and it might be interesting for the wider community of enhanced weathering. Thank you very much.